Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Suneel Kumar Bandara. Students, in this basic electronics through topic wise MCQ series, we have completed 6 sessions. It is the 7th one. If you want previous, just click on the playlist. Okay. And these series are very much useful for all your competitive examinations for both electrical and also electronic engineering students. Okay, let me start the session, guys. I think we have completed all the diodes based questions, including special diodes also. Now we have to start with the transistors. Yes, this is the first question, guys. BZ is a dash control device. I think all of you know this basic level question. First of all, we have to discuss basic level and then we have to discuss medium level. BZ is a current control device. Okay, here no need to by heart, guys. In BZT, any configuration, common base, common emitter, common collector, in all the configurations, output is nothing but current, input is also nothing but current. Okay, so generally we will take in case of common base, common emitter, common collector, common base. In this, IC is equal to alpha into IE plus IC naught na. Here common emitter, IC is equal to beta into IB plus 1 plus beta into IC naught na. Here I is equal to gamma into IB plus gamma into IC naught. Correct? That means all in terms of current. All in terms of current. Okay, so it is a current control device. Generally, by controlling the base current, we can control the output. Okay, so it is a current control device. If you can consider FET, MOSFET, or op amp, all these are voltage control device. Voltage control device. Coming to the next question. In BJT, which is heavily doped terminal, we know BJT may be either P, N, P or N, P, N. Okay, so the BJT may be two type of transistors are there, PNP and NPN. So here it is the emitter base collector, EBC concept. Emitter base collector. That means it has three terminals. Three terminals. One is the emitter, one is the base, one is the collector. So if you can consider, it is the input, it is the output terminal, and it is the base terminal. So emitter. So from the emitter we are ejecting the electrons. So that means emitter must has to be heavily doped. E, that is nothing but emitter. Emitter is a heavily doped terminal. Okay, and base is nothing but like a junction. It is a lightly doped. Base is lightly doped, and collector moderately. Okay, heavily doped terminal emitter. Very important question. Very important question. And how many junctions we have? It has three terminals. And how many junctions? P to N, one junction. N to P, also one junction. So 1 plus 1, it has two junctions. There is no junction found between P and P and between N and N. Okay, correct? Two junctions. That is two PN junctions. Okay, coming to the next one, which is large in size. Here, collector is generally used as the output, so it is used to collect the current. So collector has to be large in size. Collector large in size. Coming to terminals, base, it's doping, and coming to the size, it is lightly doped and small in size. Coming to emitter, emitter heavily doped. So to eject the electrons, it has to be heavily doped, and size moderate. And the next one, collector, collector used to collect the current. So size has to be large in size. Okay. and doping moderately doped. These are the very important points. Coming to the next question. BJT has how many PN junctions? Just now I have given a P, N, P. So P to N, one junction, N to P, one junction. It has two junctions. Not only in P and P, N, P, N also. N to P, one junction, P to N, one junction. Two junction. Okay, there is no junction is found between N to N and P to P. If emitter junction is forward bias, collector junction is reverse bias, then the application of BJT is dashed. Then the application of BJT is dashed. This type of questions are very important, guys. Here, emitter junction. What is this emitter junction? If you can consider, it is the base, emitter, collector. This EB junction. This EB junction is also called as JE. JE or EB junction. Both are same. Or you can also say emitter junction. Okay, so if you can consider, it is a PNP transistor. P to N, one junction is there. In the same way, this is the JC junction type. JC junction means junction between collector and base. JC, that is CB junction or collector junction. Okay, so these are the main terminals, emitter and collector. Okay, so emitter JE junction, collector JC junction. So based upon this, it is forward bias and reverse bias. How it will be act? How it will be act? For this, let us take JE junction or EB junction and JC junction according to the region in which it is operated and coming to the applications. First of all, this both are in forward bias. Both are forward bias means it is like a short circuit on switch. On switch means you can say it is acting as a saturation region. So it is like on switch. So for this, it is normal application like a switch operation. And the second one, if first junction is forward bias and second one is reverse bias, it will be in active region in which it will be act as amplifier. This is the main important application of the transistor. Okay, and the next one, if you can consider, first one is reverse bias and second one is forward bias, it is inverse active. Inverse active in the sense opposite of amplifier. What is opposite of amplifier? Attenuator weakens the signal. Amplifier strengthens the signal. Attenuator weakens the signal. And the last one, if both are reverse bias, guys, it may not allow any current. That means it is in cutoff region. Cutoff region in the sense it will be act as off switch. Off switch. So it is the main application of the transistor. So if you want to operate in active region, that means it is in amplifier, then first J junction has to be forward bias, JC junction has to be reverse bias. Okay, JC junction has to be reverse bias. So here first one forward, second one reverse bias, it is like amplifier. So the answer is option A. Coming to the next question, guys, note down all of this, very important. When junction transistor is operated under saturated condition, saturation means both are in forward bias. Both CB and EB junctions are in forward bias. So answer is option A. Very simple. If they have given the question in any manner, if you know the things, then you can easily give the answers. Okay. The collector to emitter cutoff current ICEO of transistor is related to collector to base cutoff current ICBO, as alpha is the current CB current gain of the transistor. We know very well alpha, beta, gamma, these are the nothing but current gains only, guys. nothing but current gains in respect of CB, CE, CC. Okay, alpha is the current gain of CB respectively. Beta is the current gain of CE, gamma is the current gain of common current. Okay, common current. Here we know ICEO is equal to 1 plus beta times of the ICBO. Okay, so ICEO is the higher than the ICBO. So in this case, if you want to get this in terms of alpha, just we have to substitute the alpha in terms of beta. Beta is equal to alpha by 1 minus alpha or 1 plus alpha. So many students having doubt on this. We know the relation alpha is less than or very much less than beta, and beta is less than or very nearly equal to gamma, correct? Or you can say less than gamma, correct? So that means beta value is always higher. If you want to get high value, what about the denominator? Has to be low now. If you want to get denominator as low, you have to place minus or plus minus. Then when it is low, then beta will be higher. Okay, that is a simple trick to remember the relation. If you want to get alpha, alpha is equal to 1 by 1 plus, alpha is equal to beta by 1 plus beta. Correct? Alpha is equal to, denominator has to be less. Denominator has to be more. Whenever denominator has to be more, this one has to be less. Correct? So here plus you will get, here minus. Here minus. All of you note down these two tricks. These are very, very important. Denominator is low. Alpha value less than 1, guys. Current gain in common base. Common base, voltage gain is the highest, current gain is the lowest. That is less than 1. Okay, all of you clear? So then ICEO is equal to 1 plus beta is nothing but alpha by 1 minus alpha. So 1 minus alpha plus alpha. Alpha cancel out, 1 by 1 minus alpha. Okay, 1 by 1 minus alpha into ICBO. That is nothing but answer C now. Option C. ICBO is equal to 1 by 1 minus alpha into ICBO. Okay, all of you clear? Now coming to this question, in bipolar junction transistor, an increase in magnitude of collector voltage increases the space charge width at the output junction diode. This causes the effective base width to decrease. This effect is known as dash. This effect is known as dash. So if you increase the collector voltage, what is happening? The base width is going to be decreases. The base width is going to be decreases. As base width is decreases, what is happening, guys? As base width is decreases, then current easily flow from emitter to collector, correct? Then collector current increases. So it reaches its rated value as early. Collector reaches its rated value as early. So that effect is nothing but early effect. That means due to this early effect, IC increases. IC increases means we know alpha is equal to IC by IV. As IC increases means alpha increases. Alpha increases means beta also increases. Beta is equal to alpha by 1 minus alpha. Na? So due to this early effect, base width is decreases. That is the first point. Collector current increases. That is the second point. Alpha increases. Beta also increases. Okay, these are the effect in case of early effect. Coming to the next one, the early effect in bipolar junction transistor is caused by nothing but collector voltage. Okay, if you increase the collector voltage, a large collector to base reverse bias voltage, that is large collector voltage. Okay, due to that we are getting early effect. And the modulation of effective base width by collector voltage is known as early effect. They have given the definition. Hence, reverse collector voltage dash. Already I have given if reverse collector voltage increases, base width decreases. As base width decreases, collector current increases. Then alpha increases, beta increases. Okay, increases both alpha and beta. Na? So the answer is option A. Answer is option A. Coming to the next one. Self-destruction of transistor due to cumulative rise in collector junction temperature is called as dash. Let us take one formula. IC is equal to beta into IB plus 1 plus beta into IC naught. From this one, we can easily understand, guys. Self-destruction of transistor, that means it is destruct by own itself by cumulative rise in temperature. This effect is called as thermal runaway. Temperature, thermal runaway. How it will be happen? Whenever collector junction temperature, that is collector junction temperature, whenever the temperature increases, what will happen? Temperature increases. IC naught is going to be double now. For every 10 degrees centigrade rise in temperature, IC naught is going to be double. As IC naught is increases, what happened to the IC? IC increases. As collector current increases, then power dissipation increases. As power dissipation increases, heat will be increases. As heat increases, what happen? Again temperature increases. This is a cumulative cycle. Okay, again IC not increases, again IC increases, again power loss or power dissipation increases, again heat increases, again temperature increases. Then whenever it reaches to beyond safe value, okay, that means the temperature increases beyond safe value or IC naught increases beyond safe value, then it will be destructed by its own. This self-destruction of transistor due to cumulative rise in temperature is nothing but thermal. If you want to avoid this thermal runaway, then we have to put VCC is always less than or equal to VCE is always less than or equal to VCC by 2. Okay, VCE is always less than or equal to VCC by 2. Then we can eliminate this thermal runaway to avoid thermal runaway. This thermal runaway is possible in BJT only. In case of FET, no thermal runaway. In that, leakage current is very, very less. Okay, so higher input resistance, due to that leakage current is also very less. So there is no possibility of thermal runaway in FET. That is advantages of the FET. Okay, here to avoid the thermal runaway, we have to give the biasing. VCE is always less than or equal to VCC by 2. Coming to the next one. Yes, here they have given the question. To avoid thermal runaway in the design of analog circuit, the operating point has to be set such that VCE is always less than or equal to VCC by 2. So the answer is option B. Answer is option B. Okay. Okay, students, in the next session, we will discuss the remaining questions. Maybe the questions belongs to alpha, beta, and those relation and small example problems, and all those we will discuss. Okay, if you have not subscribed this channel, please click on subscribe button and click on description box, guys. In that I have given the Telegram link and how to download the PDF and many more I have given. Okay, so don't miss. Click on description box. Okay, and also encourage me with your likes and comments. Each and every student comment is important for me. That will give some boosting to make the videos. Making videos is not that much of easy, guys. Okay, so nowadays you have so many YouTube channels, but any that is making of the video is not that much of simple. We have to prepare and we have to design the questions and we have to spend a lot of time. Nowadays we have so many web series are there, so many OTT movies are there. I can also enjoy those. Okay, but I want to help some students to get their dreams. Okay, and so many students are feeling that, sir, you are giving the videos and you are getting the money now. No, yeah, here a very little bit. Okay, for example, if any video getting nearly 10,000 views, 10,000 views, then maximum we may get 100 rupees. Okay, for every 10,000 views, maximum 100 rupees or 50 rupees. It is between 50 to 100. Okay, so that means if I upload nearly 50 to 60 videos in a month, then maximum I may get, nowadays I'm getting very less views now, so 5,000 to 10,000 views. So for 1 month, 100 rupees. So very less. So don't think about sir getting money and all those. That's why he's pushing, watch my classes, share my classes, like that. I may not get anything, guys. Okay, so don't think about myself. Okay, so think about yourself. So this content is very much useful, so try to watch. Don't be in negative manner. Okay, always be in positive manner and try to keep preparing. Okay, so whenever the notification is the notification comes, then you are the person who have completed all the syllabus, then you can easily get into the job. Okay, once you got the job, you will get 50 to 60,000 rupees as your first salary. Okay, so whenever you are in demotivation mode, okay, then think about that and you will get the interest. Okay, thank you so much, guys.